Ignore that link. Use this one. Okay. Can you put your thing back up? Yeah. That'd be great. Okay, I think I actually got this thing working now. So, my goal, now obviously number one, in terms of your projects, the reason why I know not a lot of you have started it is because not a lot of you have even contacted me in regards to the house and car that you've selected. Now, for those of you that have contacted me, I've tried to get back to you as quickly as humanly possible, simply because, you know, well, even though I was out for 3 days last week, I wanted to make sure that I was on top of this information for you and being able to answer questions. Now, in regards to the assignment that you had to do for me on Thursday, I haven't looked into what you've turned in yet, but I am going to look into what you turned in because it was a review, but I still wanted you to get it done, and you're still going to get credit for having it gotten done. But I would like to go over said problems for today. I know that there were a lot of people who messaged me like in the moment in that class period, Mr. Markey, I don't have a signal, I can't upload a picture. I will do it once I get connection, and you did afterwards, so thank you for that. If you did send me that message, obviously I do have it, and we'll kind of go from there. What I would like to do for a good portion of this class period is I would like to go back to that review worksheet that you guys worked on Thursday. And I'm going to strongly suggest that whatever information we end up putting up here on the board, that you copy down as well, because it is going to be the review before the test. See, yes, you do have a project due tomorrow that we have been working on for quite some time. I'm uncertain as to which date I'm going to assign it. It's probably going to be tomorrow at the end of the school day after the project has been due, but I am going to be assigning you an online major. So please be aware of that. It is on the same material that we've been covering for multiple weeks, but please make sure that you are staying on top of it. And yes, for those of you joining us in the live stream, I don't know why I do know why I was having such an issue with the previous stream. For some reason, things just, well, by the way, it was a warning. That's what the YouTube said. It specifically used the word warning. Is there a difference between a warning and a strike?
A strike is like one time, a warning is like getting a strike, but you get actually a strike. I think it's 2 that you got.
Okay. They definitely labeled it a warning. So, oh, because I in my cryptology class, what's up?
Just talking about project.
In my cryptology class, I was showing a video, the historical YouTube video in regards to the Enigma project. Yeah, and in the middle of showing that video, I got an email from YouTube saying, "Hey, copyright." Like, sorry, I'm not trying to make money on the YouTube video. That's what they think, you know, even though I'm not like partnered there, but whatever. It is what it is. And just for the record, for those of you in the live stream, thank you again for commenting. I took a picture of those who had commented in the other one. And I will, of course, compare to what do we got here as well, just to make sure I got everyone that we need. So in the meantime, what I'm going to ask of you, if you do not already have them out, I'm going to need those notebooks out and open. Which calendar? Well, keep in mind, I just got in today after that many days. And what is today, Monday? Monday the 22nd, so I got to change the 2 there. There you go. So. Huh? How'd I do that so fast? Have you not known that I am a genius?
I mean, in like 11th grade math.
You don't know me. You don't know anything about me.
I know you're a math teacher.
You don't even know this is my real name.
Yo.
Anyway. No, that's not what I meant. Students always assume that they know everything about me.
I mean,
Oh, when you assume, you make a bad word out of you.
he's a family man. What do you say?
Huh?
Are you a family
When you assume, you make a bad word out of you.
I never did it.
All right? People do assume with their minds. So,
That's not.
well, ladies and gentlemen, I had these problems for you to do the other day. You see what he's trying to do right now? He's trying to save face. You know the difference between you and me? The difference is I don't care. So, to this, these were the problems that you guys had to do for me off of that worksheet. On Thursday, that assignment was posted on the time that you guys were to get that, during your actual class period. And this is the worksheet that popped up. Now, obviously, I didn't have you doing every single problem off of this review, just these problems, but I would like to go through them one at a time and remind you of what it is that you need to know in preparation for this online major. Now, again, for those of you in the chat, I do apologize for the issues with the live stream this morning. I do have the correct live stream up and running on my phone right now, so that if you do have any questions, you can, of course, post them there, and I will get back to you. So let's get right there. So number one is reminding you as to how graphing is actually taking place. Now, it says to find the domain and range of the function shown there. Now, I'm going to actually bring up my calculator, and I'm going to type that particular function that is on the graph into my graphing calculator so we can visually see it. It is y equals 4 times 2 to the x power. Let me do that here. 4 times 2 to the x power. Now, again, remember, the entire concept of exponentials is that there is a variable in the exponent. There is a variable in the exponent. So let me graph that, see what it looks like. That is not what you need to see. That's from AP Statistics. That's what you need to see. There we go. Let's call this Chapter 7 a review. I'm giving myself a title right here for my notes. I'll show you what I wrote down in a minute. Now, there's a lot that you can get out of this. Obviously, this thing is an X. Well, actually, do you know? Do you know if this is a growth or a decay? Definitely a growth. And how does one know? I could draw you a growth on the board that would be going down. I know what you're trying to say. I know what you're trying to say. Technically, both of these drawings, it's terrible. Both of those drawings are growths, both of them. The idea, and I see what you're trying to say, you're trying to put those words together. As you read it left to right, it's growing. It doesn't matter if it's growing positively or negatively. It doesn't matter if it's growing positively or negatively, but when you go left to right, it's growing. See, the thing is, this is still a growth. Mr. Margie, it's going down. I know, it's going into the negative direction, but it's still growing. Well, what in the world grows negatively? I don't know. How about our national debt? Doesn't that grow negatively? Yeah, and it's still growing. It's still a growth. For the most part, I guess you could say that, you know. For the most part, if you have something that's growing in the negative direction, that could be, you know, clearly something that's like, you know, not good. I mean, there probably are some good examples, but now back to this example, though, on the board that's in blue on the graphing calculator. Definitely a growth, definitely hits that asymptote. When I look at the problem itself, it's asking for the domain and range. Now, again, domain is talking about how far left and right this graph actually goes. I'm going to do a little sketch right here in my notes. And next to this equation, actually not next to it, underneath of it, I'm going to write this. Y equals a times b to the x minus h power plus k. Now, I write that down because that is the general form of an exponential problem. The general form. The h and k, the h shifts this thing horizontally, but we don't often see an h kind of sitting there in the exponent. What we do see more often than not is that k value. That k value determines how far up or down this graph is going to shift. Now, I'm going to tell you, for domain, the domain of every single exponential, the domain of every single exponential is that. Negative infinity to positive infinity. No matter what, that is the domain of every single exponential function. It stretches left forever, it stretches right forever. That's a fact, that statement there. The range, however, is limited. It is limited by the asymptote. Now, I haven't used that word probably in a couple of weeks now, but when I'm talking about asymptotes, an asymptote is that invisible barrier that the graph will approach but will never cross. General idea being, well, there's some kind of a limit to how far things can go. If you have a bank account, theoretically, you shouldn't be able to go below $0. Now, yes, there are, you guys know about overdraft fees? Yeah. Have you experienced overdraft fees? Okay. Some people have, it's like,
Taxes.
well, it's not just taxes. Say again?
I have one.
Yeah? Was it TD Bank and you went under like $100 or something?
Yeah.
Yeah. TD Bank is like notorious for that. It's ridiculous.
It wasn't a lot, though. I don't remember how much it was, but I had money to put in it.
No, I got you. I know, but yeah, they do it automatically with computers and stuff like that. Theoretically, you can't go below $0, though. In this case, the k value for our example represents what the graph will approach but never cross. It's approaching 0. It'll never actually get to 0. The range is technically 0 to infinity because it goes from that 0 horizontal line all the way up forever. But make sure that you are putting parentheses. Parentheses. I'm going to show you the worksheet in a moment and the choices that they had there, but you got to have parentheses around that 0 because it's never actually reaching that 0. It will never touch that 0. It'll always be something greater than that 0 or whatever the asymptote actually is. If you look at the actual choices for that problem, if I can scroll over a little, here we go. They talk about the domain and the range. They want the domain and range of that function. This notation's a little bit weird, but they're just basically saying like the domain, all the x values greater than 0. Well, no, we just said the domain stretches left and right forever. It clearly cannot be that one. Oh, the domain is all real numbers. Yes, the domain is all real numbers. If it's going from negative infinity to positive infinity, you could say that the domain is all real numbers. So it has to be B or D. The range, it's all of these values that are greater than 0, clearly since it's above it, which is why the answer has to be that one. Y is greater than 0. And again, notice it says greater than 0 and not greater than or equal to. It cannot be equal to. It can't be. Just for reference, for those of you in the chat, before I forget, this PDF is available in Google Classroom from last Thursday's assignment, the Thursday that I was out. So if you have trouble seeing the PDF on the screen, please go see that PDF from your Google Classroom. Next one I had you do is number 2. Number 2, which function represents an exponential growth? Actually, let me ask you a better question. Which one of these functions is not exponential? G is the only one that's not exponential. It's not exponential. And the reason why you know, well, tell me how you know. Technically, it's a fourth degree polynomial. I agree with that. But there's something a little bit easier to recognize. It's the only one where the variable is not in the exponent. It's the only one where the variable's not in the exponent. That's what makes it not an exponential. F, H, and J are all exponentials. Now, they want to know which one is an exponential growth. Now, yes, you could type this in. I'm assuming you know what it looks like based on the fact you looked at the equation on the graph. You don't actually have to do that. You could. You totally could. But you don't have to do that. Ladies and gentlemen, which one of these letters, A, B, X, or Y, will determine whether or not you have a growth or a decay? Which one of those four letters, A, B, X, or Y, yes, will determine whether or not it's a growth or decay? It's the B value. And I'm going to write this into my notes in a moment. But the B value determines whether or not it is a growth or a decay. And I've written this before in our notes. I'm writing this down because it's a review. But in y equals a times b to the x, if b is greater than 1, you have a growth. If, and look how I'm writing this, if b is between 0 and 1, then you have a decay. Let me remind you of something. I've said this line before. What can b never be? What can b never be? There's only two instances of an exponential. You can either have a growth or you can have a decay. If b is greater than 1, you will have a growth. If b is between 0 and 1, you will have a decay. Say who now? But what number, what value of b will determine that? Yeah. Can't be 0. The b value can never be 0. What else can it not be? Can't be negative. Can't be negative. What else can it not be? Lame. Can't be negative. Can't be 0. Can't be a 1. Can't be a 1. Let me show you. You mentioned standstill. I like that phrase. Check this out. Well, watch this though. Let me change that 2 to a 1. Now the b value is 1. Watch what happens when I graph it. It's kind of like the epitome of a standstill. It doesn't change. So to speak. It's missing the other vertical blue line. But my point being, though, is it can't be 1. It can't be 0. Watch what happens when I do a 0 here. You're all about Denmark. And then let me make it negative. Negative 1, let's just say. Watch what happens here. Graph. It's nothing. It's like a bunch of random dots. Ugh. Anywho's, it's... Which one is a growth? It's J. J is the one that's a growth. F and H are both decays. G is neither. Then I had you do number 3. Now, with number 3, there's a number of different ways that you can go through this. There's a number of different ways you could try this problem, number 3. But you could do this. Actually, there is one absolute easiest way to go about it. They say, hey, which of the following exponential functions pass through those 2 points? 0, 4. So if I plug in a 0, it should get me a 4 back. There's only one function up here where you plug in a 0 and it gets you a 4 back. Tell me what happens when you raise something to a 0 power? You get 1. And if you plug a 0 in right here, 6 to the 0 power is 1 times 4 is 4. That's the only one that works. The answer is A. That does show it, though. I'm going to put the next one into our notes. The next one does require a bit more. So let me write it down first. 8 to the x plus 2 equals 32. 2x plus 4. There we go. Boom. You have to solve this. And there is a variable in the exponent. Oh man, Ms. Markey, do I have to use logarithms? Not for this one. This problem you don't have to use logarithms for. You do not have to use logarithms for whatsoever. Because there is a way of changing these 2 bases. There is a way of re-expressing these 2 bases so that they are the same number. There is a way. If you spent some time with a calculator, it wouldn't take you that long to figure out that you can re-express the 8 as this. 2 to the 3rd power, 2 cubed. It shouldn't take that long with just messing around 8 divided by this to figure out that it's 2 times 2 times 2. 32, it shouldn't take that long to figure out that 32 is 2 to the 5th power. That is what you need to do first on these problems. That is the first thing that you need to do in order to get these problems done correctly. Because if you have them as the same base, well, I got to clean up the exponents a little bit. Let me clean up the exponent just a little bit here. Somebody tell me what the heck I just did. That's a 10 right there. What the heck did I just do here? How did I clean up those exponents? How did the parentheses disappear? Yes. I multiplied power to a power. I multiplied the exponents together. I had to take this 3 and multiply it by the x plus 2. I had to take this 5 and multiply it by the 2x plus 4. Yes, that is what I had to do. So, there is a very important property using exponentials, which basically states, and we have this written down, and I can't remember the exact wordage, but I'm going to write it like this. If a to the x equals a to the y, if you have the bases the same, can't see it, there it is, then you can say that x equals y. That's written in our notes from I don't know when. From that, you turn it into an Algebra 1 problem. And again, I say Algebra 1, and you feel that tingling sensation down your spine of PTSD. I got to solve that thing. All right, I'm just going to subtract the 3x, subtract the 20, divide by 7. This is what we should end up getting. course, we can check our answer, which I'll check our answer in a moment. I will check our answer in one moment. Oh, that's interesting when you plug it back in. It really is messed up. But you got to get the bases to be the same. If you actually plug it back in, you'll get 8 to the 0 power equals 32 to the 0 power. Yes, clearly it's 1 equals 1 when you plug it back in. What a weird problem. Let me check the choices. Yep, there it is, -2. -2. Then I had you jump to 6 and 7, 8, 9. Hilarious joke. Oh, there we go. Now we're getting into logs. Excellent. With number 6, they wanted you to write this in logarithm form. So again, for our notes, I'm going to write down the following. Y equals b to the x power versus log base b of y equals x. This is exponential form. This is log form. You need to know how these two forms, it'll focus in a moment. There it goes. You have to know how these two forms relate to one another. How you can turn one form into the other form. You need to know that for your project, of course, because you're going to be turning certain exponential forms into logarithm forms to be able to solve them, to figure out how long it takes for certain things to devalue or double or triple in value or whatever. But if I'm looking at this problem, number 6, it wants you to write 4 cubed equals 64. Come on, you. In logarithm form. Well, I'm literally going to follow that same pattern that I have above. The 3 is my exponent. The b is my base, and it's equal to 64. The 64 is my y. The base that is on my exponential is the same base that will be on my logarithm. Remind me, what do logarithms do to exponents? What do logarithms do to exponents? Do you remember? Say it anyway. You could say that. How about that? Let's not say which side, but let's just say this. They do move them. Logarithms get the exponent by itself. That's the key. Logarithms get the exponent, ladies and gentlemen, look where I'm pointing. They get the exponent by themselves. That's the whole thing. Logarithms allow you to solve for exponents. Logarithms allow you to isolate the exponent. If you can get that exponent solved for, well, that's a step in the right direction. Notice the choices. The choices had the numbers all in mixed up locations. For number 6, the correct answer should have been J. That last one on the end, it should have been J. But then for number 7, they want you to go the opposite direction. They want you to put it into exponential form. Oh, log base 12 of 144 equals 2. Now, for this one, for number 7, you could have guessed and gotten it correct. For number 7, you could have absolutely, not even guessed, but use your knowledge of the relationship between 12, 144, and 2. 12 squared is equal to 144. Absolutely 100% yes. But again, it works the exact same way. The base on the logarithm is the base on the exponential. The exponent in the logarithm is by itself. Well, the base raised to the exponent power equals 144. So yeah, that one was a B. But then for number 8. Oh, for number 8. They wanted you to evaluate log base 2 of 8. Now, there's a few different ways to do this. I'm going to show you a couple right now. First, you could have written this in exponential form. Could have been like 2 to some unknown power equals 8. And then solely based on that relationship, you could have figured out that x equals 3. Or you could have gone straight to your calculator and done log base 2 of 8, which I assume a lot of you did. That's perfectly fine. You have the calculators to do that. Let's go there so I can remind you where it is. If you go to the calculator, get rid of that. There we go. Math, log base 2, 8, spits out a 3. Because 2 to the 3rd power is 8. That's the reason why that calculation works. Logarithms are nothing more than the inverse operation of exponentials. That is how they relate to one another. One tells the story moving forward, the other tells the story moving backwards. Then I even gave you number 9 at the bottom there. I'm going to write this down and flip my screen over so you can see it. There we go. This problem, you can't just type directly into a calculator. You can't just do log base 3 of n because the calculator won't give you the correct answer. It won't. Instead, you need to rewrite this problem in exponential form. Well, if this is the exponent by itself, 3 to the 2nd power equals n. That is the proper exponential form. Oh, 3 squared. The answer should just be 9? Yes, the answer should just be 9. And it is. That is the relationship from logarithm form to exponential form. If I check the answers, let me check the answers. Yep, there it is. D. That one works. I mean, clearly it works, but it works. I also gave you these 5, 12, 13, 15, 16, and 20. Let's scroll down to number 12. Now, I'm going to put number 12 on a separate sheet of paper. Number 12 utilizes the newer property that I introduced to you last week. I'm going to write this down exactly as is, and we're going to talk about what the heck is going on here. There we go. Spend a tiny bit more time with this problem. I can tell you right now, just by looking at the problem, based on what I know about logarithm properties, the answer is 4. The answer is 4. There's no doubt in my mind that the answer is 4. The question becomes, how do I know that so easily? You said, wait a second, why? Yeah. Also, I'm hearing music from over here that needs to be like, I feel like getting scissors and clipping earbuds or something. The relationship is this. Since these two logarithms are being added together, and since they are the same base, I can combine their innards. Remember that story I told you about my niece? Okay. Shoot, yeah. Just saying. Cut me open. combine the innards. Since the two logarithms are being added together, I can combine their innards, not by addition, but by multiplication. I can combine these two logarithms by multiplication. It is called condensing logarithms. Now, just in terms of a visual recognition, what do you notice about the two logarithms? They're the same. They're the same type of logarithm. There's an infinite number of logarithms. There's an infinite number of logarithms, but these two are the same. How do you know they're the same? Yeah, as a base. They both have 6 as the base. Since they're both the exact same thing, technically speaking, just like we did with the exponentials earlier, you are allowed to do that. Because you could get that logarithm off the problem, off of both of them, by taking 6 to the power of both sides, and it cancels out that logarithm, leaving you with 4. That utilizes the property. That utilizes the property of condensing those logs together. That's how I knew the answer was 4 right at the beginning, just because I know it's 10x equals 40. Yes. But you have to know how the property works. You have to know how that property works. Number 13. Number 13 definitely wanted you to use a calculator. You can't do number 13 in your head. 4 to the x equals 20. This is the type of problem where you definitely have to rewrite this as a logarithm. Log base 4 of 20, it gets the exponent by itself. From here, it's a simple matter of going to the calculator to get that part done. Because there's no stinking way that you're going to get this done in your head. There's no way you're going to get log base 4 of 20 done by yourself. Is you running a race over there? You sure? Yeah. I hear shoes sliding. Ah. Whose feet was it? Yeah, that sound.
No. That's not like, that's not a base.
You literally just made that sound like 2 seconds ago. Oh no, wasn't? Yeah, still hearing that music. Still hearing that music. It's interesting. No, the music's not from over there though.
I'm sorry, not from the way. I'm sorry.
Oh man, I don't even know what to believe anymore.
I'll lower it down.
My word. I gotta say, we have the best conversations. Put in those proper numbers, you get that proper decimal. Just for the sake of argument, if you were using one of the calculators that did not have that function on it, let's say I was using the calculator on my phone. I'm going to flip my camera over. I don't have that function on there, but I can still use the calculator on my phone to get this thing done. That would be log of 20, close the parentheses, divided by log of 4. Clearly, it's there, it's focusing kind of. Clearly, it's the same decimal, though. Log of 20 divided by log of 4. Where's my eraser? I don't want to throw a marble. I need like a little eraser or something. Nope, not there. Where'd you go? Oh, I can throw one of these. Ah, sweet. I got a little Nerf ball. Yeah. Oh, I missed. I was trying to hit your cube.
My what?
Your cube. No, your thing. The thing that you're in. Oh no. I can hear music from across the room. It's too loud. Yes.
Sorry.
You're not sorry. Here, catch. Oh, yes. Throw it back. Can I have that back? There you go. Oh, goodness gracious. But now the music is louder. The music is so loud. Oh, so it's my fault. Oh, goodness gracious. Goodness gracious. Huh? You want to throw it? Yeah. Be kind.
Yeah, honestly, should have put like the iPhone alarm. You should have put the iPhone alarm next to something.
Oh, America.
Facts.
So, number 15.
Burger King for lettuce. You gotta say that. Come on.
I didn't hear a word you said.
Number 15.
Is that a commercial?
No.
All right. So, ladies and gentlemen.
I was not asleep all that.
Oh, she said you were.
Yeah, Jess is also wrong.
I said it looks like.
Shh. Now, number 15 is an interesting story. Number 15 is an interesting story because if you look at the way that number 15 is worded, it says to express it in terms of common logarithms. Now, I've taught you this in the past. A common logarithm is log base what? 10, which is the button you have on the calculator. But if you're to express this, you really need to use the change of base formula, in which we re-express it like this. Now again, notice I did not write the 10 for the common logarithm. I didn't, because you don't need to if you just write the word log. It's automatically assumed to be base 10. Now here's the other thing. You want to remember the order of this, because some people tend to invert the order. In fact, if I look at the choices right here, some of the choices for number 15, you could see that the numbers are inverted. 22 and 9, 9 and 22. In fact, for this one right here, look at this one. This one, they even just multiplied them together. This one, they just combined it into a single log. But the way that I remember it is I always tried to put the base on the bottom. You put the base on the bottom. It is alliteration. Back to this. Let's see, number 16 and 20 were the last two problems that I had you do. Now, number 16. I'm going to type that into the calculator, and I want to show you something special about number 16, actually. Something a little bit special about number 16. First of all, okay, good. Okay. No. Now, if I'm looking at this, if I'm looking at this, this is ln. This is ln. There's no parentheses here, but we assume that there are parentheses around that 4. It's ln of 4. If you remember what we've done in the past, that is log base e. ln is log base e. Now look at this. Look at the relationship here. You have an exponential that is base e. You have a logarithm that is base e. Logarithms and exponentials are what to each other? What do they do to each other?
Solve each
I'm not going to use the word solve each other. I want to use something a little bit more, not drastic. I shouldn't say drastic. A little bit more descriptive. They cancel each other out. They cancel each other out. A logarithm to a certain base and an exponential to that same base cancel each other out. And if they cancel each other out, you should be left with nothing more than 4. I'm going to show you that on the calculator. But I just wanted to show that how that actually works. On the calculator, I could do it like this. E to the power of ln of 4. And you can see how that is typed in right there. The ln button is right underneath the common logarithm button. Just spits out a 4. You could do it the other way around too. ln not pi, stupid pi, e to the 4th power. You could do the same thing right here because natural logarithms, the log base e and the base of e cancel each other out. Doesn't matter what order you do it in. Yes? That's what it is. Yes. There are an infinite number of logarithms. But when you turn a logarithm to be a base of e, which e is that number 2.718, blah, 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 whatever it is. E is this one. They determined that a log base e was so fundamental that they wanted to give it its own special name. So log base 10, they refer to as the common logarithm, just because it's used most often. But then log base e, they referred to as the natural logarithm. Or in the Latin, logarithmic naturalis, which is why the button says ln. Yeah. Darren, you had a question? Were you just trying to get called on before him? Okay. What other ones I had you do? I had you do number 20. Actually, you know what? Let's do number 18 as well. I know I didn't have you do 18, but I want to do 18 as well. This actually will play into your question about log, or log base e, I should say. Here is the question. ln of 3x equals 1. Now, ln is log base e. ln is log base e. They are exactly the same thing. But now, I can convert this from logarithm form into exponential form. The base to the power of the exponent equals the innards. I have logarithm form in the middle. I have exponential form on the bottom. The only thing I have to do is divide by 3. And literally, I'm just going to go to the calculator and do just that. For this problem, e to the 1st power, well, why am I even doing that? It's just that. Divided by 3, the answer should be 0.9061. Let me just confirm by looking at the choices. Yep, 0.9061. Now, you also had number 20. Number 20 was a compound interest problem. Number 20 was a compound interest problem. However, for number 20, how often are they compounding? Are they compounding monthly? Are they compounding yearly, daily? None of those. It is compounding continuously. And you can tell by that word continuous. This is the formula that I wrote down last week that you would have to use for this problem. Instead of your regular compound interest problem, you would have to use this. Now, I'm sorry. That wasn't what I wrote down last week. That is not what I wrote down last week. This is what I wrote down last week. That's from Tuesday. That is what I wrote down last week. P being the principal, E being that constant in the calculator, R being the rate, T being the time in years. If I were to do this problem, it would be 5,000 times E to the 0.04 times 6 power. This is what it would look like. Well, it's very similar to the compound interest problem that you would be doing on the project. Now, I'm going to erase this. Obviously, I'm writing it in dry erase marker. But on the project, you would be using this formula. However, this formula depends upon the value of n. N being the number of times compounded per year. But since the problem doesn't tell you how many times it's compounded per year, it actually says that it is compounded continually. It has a continuous rate. Then there is no number that you can plug in for n. As a result, you have to use the separate formula. This other formula is how a continuously compounded problem would be calculated. If I were to just type this into the calculator literally as is, because if you're doing an assessment for me, then obviously you would be utilizing the calculator to its fullest extent, making sure everything is just typed into the proper location right there. And it spits out the answer. You just have to know how to utilize it correctly. There's no tricks to this problem other than recognizing which of the formulas you need to be using, which is why the answer was J there. Now, if you did not turn in the assignment from last week, it is now considered late. Obviously, if you had problems submitting it in the moment and you emailed me, which several people did, thank you for that. Obviously, there's an exception to that rule, and you would have, once you got Signal, you would be able to submit that information. Yes, I believe we did. Let me jump back to that one. I don't think we wrote anything down for it. But let me jump back to number 3 real quick. Come on. Yes. For number 3, because the graph went through this point, 0, 4, we simply plugged a 0 in for x, and whichever one resulted in a 4 was the actual graph. Yeah. Ladies and gentlemen, obviously, if you haven't left a comment in the chat, please make sure that you do so. You will be getting assigned that major. Do not forget your projects. I cannot wait to start putting in grades for them. Yes.